right, we'll go ahead and get started. Hello, everyone, and welcome into my channel. Happy Friday. This is my first live stream of the week, and so I'm getting used to this new schedule. Only posting lives on Fridays. So, um, yeah, I am going to be working on my board tonight. And if you're here and you have a math question or you have a math problem you want to see worked out, you can post in the chat. And in the meantime, I'm just going to be working. I somehow have been stuck on linear systems for a while, and I've decided to go ahead and work another one. And yeah, just for fun. I haven't worked one in a whole week. So I originally have this system picked out and was thinking I wanted to try to do it algebraically. But disclaimer, I don't know if I'm going to be able to do it algebraically or not. I might have to pull out matrices. So yeah, we'll just go ahead and get into it, see how it goes. So this system that I picked out has 4 unknowns. So it already has the answer in the back. So I have the solution. Just how to get the solution is kind of where I'm at right now. So with that last system, I kind of got lucky because one of the equations was only had 2 variables in it. And so that helped me to make a substitution and made short work of solving it algebraically. This system that I have picked out, I'm going to go ahead and write it on the board, but I'm not seeing immediately a good path to take algebraically. So, yeah, it's kind of somewhat suspenseful for me in that regard because I don't know how I'm going to solve this thing yet. So, anyway, here it goes. So we have W plus 2x plus 2y plus 5z equal 11. And W 2x 2y 5z 11. We have 2w plus 4x plus 2y plus 8z. That's going to equal 14. And we've got w plus 3x plus 4y plus 8z, and that's going to equal 19. And boy, even just writing the system out is exhausting. So we got w minus y plus, minus x plus y. And that equals 2. All right, so here's our system. And just making sure real quick. W, X, Y, 2, and then 1, 3, 4, 8, 19, 2, 4, 2, 8, 14, and 1, 2, 2, 5, 11. Okay, I think I've got it written correctly. And then we'll go ahead, I guess it'd be useful enough to go ahead and state the solution here. Let's see. Where do we want to put the solution? I didn't leave a whole lot of room up top, but we can fit it in here. So it says W is -2. x is -5, -1 for y, and it looks like z is 5, +5. So we have this solution here. All right, so I was thinking about maybe trying to solve it algebraically. If I did that, I could. So first thing I'm seeing right here is that we have the w and the y. And that's 2y. Hang on. That's not going to work. Oh, yeah, this one right here. The 2w and the 2y. So I want to multiply the fourth equation by 2, or -2, and add it. So that's what we'll do first. We're going to take this first equation, w minus x plus y, 2, and just multiply everything by 2. So that's going to be 2w minus 2x plus 2y, and equals 4. Oh yeah, -2. Hang on. -2. And then that becomes a -4. So negative, positive, negative, negative. Perfect. So now if I add it to the second equation, I'll have 2w plus 4x plus 2y plus 8z, that equals 14. And then what we're going to do is we're going to combine like term only. So that's going to give me, so that's going to be 0. It'll be 6x plus 8z equals 10. All right. And I'm going to box this because what I want to get is I want to get 2 equations with 2 unknowns, because that is totally doable. All right, so let's try to do that again. I see the 8z here, the 8z. So let me just think if there's something I could do. All right. So it would be really nice if I could get another equation, a unique equation, just involving x and z here. So I want to be able to eliminate y and w in the same, like the same equation. And I already added those two, so I can't do the same 2 twice. This one. See? Okay. Could I take the what I could do is I could take the second equation and divide it by 2. I'll end up with no, I won't, because everything is divisible by 2. So if I take that one, divide it by 2, and then add to that first maybe. All right, so that's not going to work. So what about, I'll have to maybe try to substitute now. So what I'm going to do is I'm going to take this fourth equation and I'm going to solve it for, we'll solve it for x. We'll solve it for x. All right, let's do that. So w minus x plus y equal 2. And then we're going to subtract w, subtract y for both sides. So it's going to be negative x equals 2 minus w minus y. And then just multiply everything by a negative. We get x equals negative 2 plus w plus y. All right. And then what we're going to do is, we'll say w plus y minus 2, box this. And then everywhere that there's an x now in these other 3 equations, we can plug it in. Wait a second. Let's back up and not solve this one for x. Let's change that. We might need x. Rather than eliminating x, let's eliminate w. Let's try this again. W. Actually, let's try and eliminate y. Okay. So minus w plus x gives us y equals 2 minus w plus x. So box that. And then we're going to take the other 3 equations here. And we'll plug in for y and see what happens. So first one is w plus 2x plus 2 times y. And open up a parentheses, and then you're just going to insert what y is equal to 2 minus w plus x plus 5z equal 11. And then that's w plus 2x plus 4 minus 2w plus 2x plus 5z equal 11. Combine any like terms. So 2x and 2x. So, and w minus w. So negative 2 plus 1 is negative w. 2x plus 2x is 4x. And then we have plus 5z. And then we're going to subtract 4 from both sides. So that's going to equal 11 minus 4 is 7, not 6. Okay. And so I'm going to box this one. And I have to repeat that process for the other 2 equations. So the next one is this one here. 2w plus 4x plus 2y plus 8z equal 14. And then I'm just replacing for y here. So 2w plus 4x plus 2, open your parentheses, insert y equals 2 minus w plus x plus 8z equal 14. And then just use order operations, distributor property here, 2w plus 4x. 2 times 2 is 4, 2 times negative w is 2w, negative, excuse me, 2 times x is plus 2x, plus 8z equal 14. All right, so now combine like terms. W's are actually going to disappear here. So we've got 2 minus 2 is 0, 4x plus 2x is 6x, and then 8z. Oh, this is the one that we already got. It's this one. All right, minus 4 is 10, equals 10. So that's why that one already led to it. It's because we already did that right here. Dang it. Anyway. So that's equals 10 because minus 4 here. All right, so we have that one. And then we've got to do it one more time, this one. So w plus 3x plus 4, open the parentheses, 2 minus w plus x plus 8z equal 19. Okay. All right, so important. All right, w plus 3x. 4 times 2 is 8. 4 times negative w is negative 4w. 4 times x is 4x. Plus 8z equal 19. All right, combining like terms, we're going to have 7x, negative 3w, 8. So we have 8z, and that equals minus 8. 11? Is that 11? All right, so I need to box this as well. So we have this mini system now. And we've eliminated y. And so what I really want to do is eliminate w, because we have this one. So we're going to take, we have this, so let's just duplicate. So we're going to take these two, and we're going to, I'm going to multiply this one by negative 3. So it's negative 3 times negative w plus 4x plus 5z equals 7. So that's going to be a positive 3w. 3 times 4 is, it's going to be a negative 12x. And 3 times 5, and it's going to be a negative 15z. Negative 3 times 7 is a negative 21. Okay. So I have this now. What I'm going to do is, so I multiplied this one by a 3. I'm going to add it to this one, just the third one. So negative 3w plus 7x plus 8z equal 11. I'm just going to add these and eliminate one that way. So that's going to be 0. 12 and 7 is negative 5. X and 15 is 7, negative 7. Z. And then 21 and 11 is 10, negative 10. Better check the math there. All right, perfect. So now that we have these two equations here, we can now, we've got our subsystem, and I can solve. So let's go ahead and do that. So over here, we'll have 6x plus 8z equal 10. And we have negative 5x minus 7z equal negative 10. So elimination is possible, but we'll have to multiply both equations by scalars. This one, so the top one could get multiplied by a 5, and the second one could get multiplied by a 6. And in that regard, you could cancel out x. So I guess we could go ahead and do that. You could also end up with fractions solving for one of the variables. We'll just go ahead and do this since I already got it. So 5 times 6 is 30. X, 5 times 8 is 40. Z, and 5 times 10 is 50. And then the second equation, we have 6 times 5. 6 times 5 is negative 30. 6 times 7 is negative 42. Z, and 6 times negative 10 is negative 60. Now when we add the equations, we'll lose x. So that's 0. 40 and 40 is negative 2z, and that equals negative 10. So it looks like z equals 5. That's correct. Good. That was a lot of work getting there. And really, we can, since we have z, we can go ahead and plug in any of these other ones and figure out x. So let's do that next. So we have 6x plus 8z equal 10. So that's 6x plus 40 equal 10. 6x equal, so 10 minus 40 is negative 30. It looks like negative 5. X is negative 5. Yep, good. So we have x and z. We can plug in here and figure out what w is. So we have negative w plus 4 times 5 plus 5 times z and that equals 7. So negative W minus 20 plus 25 equals 7. So we've got negative W plus 5 equals 7. So it looks like negative W equals negative 2. Perfect. All right. So we just have y to find now. So we can use this one for y. We'll put it right here. So we'll say y equals 2 minus W. Don't forget that extra negative. Plus x, which is also negative. So that's 2 plus 2 minus 5. So 4 minus 5 equals negative 1. Perfect. All right, so we found them. Negative 2, negative 5, negative 1, and positive 5. Yeah, so systems with 4 variables, they are doable using algebra, the old-fashioned substitution elimination method. So totally doable. They're a little challenging. And again, I have yet to find one that I did not have to use a combination of substitution and elimination. It's probably possible, but I have not found it yet. And it took me under 30 minutes to do it, so that's a modern marvel in itself. All right, so I am going to go ahead and probably stop there. I'm being lazy, I know. 30 minutes a week is not it's not enough, but I'm just really thankful for the time that I do get to be here and presenting math in some form in this capacity. And so if you watch my video, thank you for watching. And if you have a math problem, don't hesitate to ask me. And I will be back next Friday. Only doing live streams 1 day a week right now. I'll be back next time, and I'll go ahead and sign off. I'll say bye for now. See you next time.